Hello, so now let's talk about function representation if the function is of Boolean type. So what is a Boolean function? Boolean function is a mapping from Bn to B. Okay, so this means we have n variables and here we have only one Boolean variable. Okay, so in order to represent a Boolean function, we need some definitions. So a literal y is a Boolean variable or its complement. So then if we have a Boolean variable x, so its corresponding literal can be x or x complement. Okay, so this is my literal here. Okay, now note that another definition is the min term. So min term is what? Min term of n Boolean variables is the product of their n corresponding literals, and a max term of n Boolean variables is a corresponding sum of n corresponding literal. So when we say sum, this means the OR operation, and then when we say product, it means the AND operation. Okay. Okay. So this is just a recap of all the Boolean identities, and then if we need it, we can go to this and solve our question. Okay. Now let's talk about the sum of product representation. Now consider a Boolean function which is a mapping from again n variables to one variable. Okay, so think of collecting those values for which this is 1. Each of these correspond to one min term. How? Okay, because note that a min term is 1 for one and only one combination of its variables due to the AND operation. And this is why, because if we have x, y, z, this is equal to 1. This means that this guy should be 1, this guy should be 1, and this guy should be 1. There's no other combination which gives the product equal to 1. Okay. Now, if we talk about the literals, and we say, for example, if we have three literals, we say y1, y2, y3, this is equal to 1. So this means y1 is equal to 1, y2 is equal to 1, and y3 is equal to 1. Correct? Now, y1 can be, this means x1 is equal to 1 or x1 bar is equal to 1, right? But which one to choose? That's the same question applies for y2 and y3. So for choosing, we say this one, and in other words, we choose xi is, if xi is equal to 1, then choose yi is equal to xi because we want yi's to be 1. But if xi is equal to 0, then we choose yi to be the complement of xi so that our yi becomes 1. Okay, so what does it mean? So it means that, for example, if we have again we have x is equal to 0, y is equal to 1, and z is equal to 1, then we choose for 0 we choose x bar, for 1 we just choose y, for z, for 1 again we choose z. So this is the corresponding min term corresponding to this combination. Okay, so this is what it means. So sum of all such min terms form f. Okay, so this is the way how we use the sum of products representation. Now on the contrary, let's talk about the product of sum representation. So this is the exact opposite, that we replace some functions and you will see how. So again we consider a Boolean function and we think of collecting those values for which our function is 0, and each of these correspond to one max term. Okay, and max term is, sorry, I should write 0 here. Maximum is 0 for one and only one combination of its variables due to the OR operation. Again, if we have x plus y plus z, this is equal to 0. This means this should be 0, this should be 0, and this should be 0. Okay, that happens when all literals are 0. So if we have x, again x, y, z. So let's say we have x1, x2, x3. Then we have y1 plus y2 plus y3 is equal to 0 because y1 is the corresponding literal of x1, and similarly for y2 and y3. So this means y1 should be 0, y2 should be 0, and y3 should be 0. So this means if x1 is equal to 0, then y1 should be equal to x1, correct? But if x1 is equal to 1, then y1 should be equal to the complement of x1 because we want all y's to be 0 for the OR operation. Okay, so then we choose y is equal to xi if xi is equal to 0, and if x is equal to 1, we choose y is equal to xi complement, and then we take the product of all such max terms. Okay, example. So we'll do example for 3 variables and 4 variables. So we have 3 variables here. So just a recap, how many possible functions we can find? We can find 2 to the 3, which is equal to 2 to the 8, which is equal to 56. There are 256 functions possible for this, for 3 Boolean variables. So let's arbitrarily choose something. So we'll choose 0, 1, 1, 1, 0, 1, 0, 0. How about that? Okay. So this means that first of all we are interested in sum of products. Okay. Okay. So for sum of product, we need to choose the min term. Min term is this. We need to choose for the terms for which f is equal to 1. So then this is the case, this is the case, and this is the case. Okay. For now, for then we want the corresponding literal of this guy, this guy, this guy. So we want the literals to be 1, correct? So then this means that we will choose x bar, because x is 0 here, y is 0 here, so y bar, and z is 1 here, so we'll just choose z. Then again for this guy, similarly we will choose x bar because x is 0 here, y and z bar. For this one we will choose x bar, y, z. For this one, we'll choose x because x is 1, y bar because y is 0, and z. So we'll choose x, y bar, z. And then we'll take the sum of these one. So my function is, this is equal to x bar, y bar, z plus x bar, y, z bar plus x bar, y, z plus x, y bar, z. Okay. Okay, now we'll talk about the product of sum. Product of sums. Okay, so for this we need to consider 0 here. So we have a 0 here, we have a 0 here, and we have a 0. Okay, so what is the max term corresponding to this? The maximum corresponding to this is, remember, we need all of them to be 0. So we'll just choose x plus y plus z because all of them are 0, so we don't need to complement any. Okay, so what is the next term? So I'll just make the product right here. So what is the next one? So this should be x bar, y, and z. So x bar plus y plus z. This guy should be x bar, y bar, z. X bar plus y bar plus z. And this should be x bar plus y bar plus z. So this is my product. So each of them is a max term, and this is my product of sums representation. So very quickly now, without much explanation, I will do an example uh, for 4 variables. So let's choose something. So 0, 0, 1, 0, 1, 1, 0, 0, 0, 1, 1, 1, 0, 1, 1, 0. How about that? Okay, so then product of sum. So first is this guy. So I'll say w bar, x bar, y, z bar. Then this is guy and plus. So this is w bar, x, y bar, z bar. Okay, plus. Then we have this guy, which is w bar, x, y bar, z. Then we have this guy, which is w, x bar, y bar, z plus. Then we have uh, w, x bar, y, z bar plus. Then we have w, x bar, y, z plus. Then we have w, x, y bar, z and plus wxy z bar. Okay, so we have 1 2 3 4 5 6 7 8, and then we have 1 2 3 4 5 6 7 8. Okay, so we should have the number of ones should correspond to the number of minterms we have. Now we talk about the product of sum representation. So first 0 is this, so then w plus x plus y plus z times, so times, then we have w plus x plus y plus z bar times. So this is w plus x plus y bar plus z bar times. Now we come here, this is w plus x bar plus y bar plus z times. Then we have w plus x bar plus y bar plus z bar times. Then we have w bar plus x plus y plus z. Okay, then we have this guy, which is w bar plus x bar plus y plus z. Then we have the last one should be all bars, w bar plus x bar plus y bar plus z bar. So 1 2 3 4 5 6 7 8. So this and this represent the, so this is also f equals to, and this is also f equals to. So this is the product of sum representation, product of sum representation. This is the sum of product representation. Okay, so this is it about the brief explanation of the two types of representations we have for Boolean functions. Thanks for watching. Hope you like the video.